Right, the 2012 question on area and volume. Find the perimeter of the shape shown in the diagram. Okay, so perimeter, I always say walk to walk. So pick a corner, let's pick that one, and you walk around the shape to get the perimeter. So we have a 21 plus a 12 plus a 12. Okay, and then a side we don't know. So we need to find the length of this side here to be able to get the perimeter. Okay, so how do we do that? Right, well, the easiest way to do it is to draw a line just there and break it into shapes that you know. So this is a square then, because that's 12, that's 12. So he's going to be 12 and he's going to be 12. So let me write them in. He's 12 and he's 12. Okay, so if that whole thing then is 21, and I know this part of it is 12, this part over here must be 9, because 9 and 12 will give me the 21. Okay, when you drop this line here straight down, it's called dropping a perpendicular, and you end up forming right angles there because that line is perfectly perpendicular to this side here, and it has to be able to form that square. Okay, so now I have a right angled triangle. Can you see that? So I have a shape that's here, and there's here. Okay, so that's that one here. So he's 9, he's 12, and he's that side X that I need over here. Okay, and using trig, how do I find out that length of a side if I have the other two sides? Well, that's Pythagoras' theorem. So c squared is equal to a squared plus b squared. Okay, c is always your hypotenuse, which in our case I just called x, and it's equal to the other sides squared. Okay, so 9 squared and 12 squared, I'm getting 225. I don't want x squared, I want x the length of the side. So the opposite of squared is square root. What I do to one side, I have to do to the other. So square and square root cancel there on the left, and root 225 is 15. Okay, so that length of that side x is 15. Okay, so if I can go back now to get the perimeter and walk the walk. Okay, so again, starting this area, I have a side here that's 21 plus this one here, which is 12, plus this one here, which is 12, plus back to where I came from, the length of that side is 15. So we have 21 plus 12 plus 12 plus 15 being equal to 60. And I'm looking up for units, centimetres, not centimetres squared, because it's just lengths of side. Okay, so any of those ones that comes up in your junior cert, these are called a compounded shape, where there's two shapes literally stuck together. Break them into shapes that you recognize as best you can, and then work with the shapes either individually like we did here, or together if that's what the question asked. Okay, but the key, break it into shapes that you know. All right, let's have a look at part B. So a drinking glass in the shape of a cylinder of diameter 7.5 and height 10. Okay, it has a hemispherical base as shown in the diagram. Okay, so it comes down and then kind of goes up like that. Okay, well, that's an unusual drinking glass. Calculate the curved surface area of the cylindrical part of the glass. Okay, so just like in a previous question, when you get your surface area and volume, it's page 10 of the log tables. You go to your shape, it's cylinder in this case, except it's looking for curved surface area. So A represents the curved surface area. So you can see for a cylinder, curved surface area, A is equal to 2 pi r h. Okay, 2 pi r h, where r is the radius, you can see it here, and h is the height of the cylinder. Okay, so in R1, it's equal to 2 pi. We know that the diameter is 7.5. Radius is always half of a diameter. Okay, so D is equal to 7.5. Therefore, your radius is equal to 7.5 divided by 2. And that's equal to 3.75. Okay, and why do I do that? Well, it's the radius that I need for the formula, and my height then is 10. So 2 by pi by r by that h of 10. When I put that into my calculator, I'm getting 75 pi, okay, which is a fine way of leaving your answer. In some questions asks for it in terms of pi. This one says correct to 2 decimal places. So hit S to D on your calculator. What your calculator then does is multiply in that 3.14. So multiply 75 by 3.14, and that's where you get the answer 235 point. I'm getting 619. So rounded to 2 decimal places is 235.62 centimeters, and its area squared. Okay, so all I have worked out there is the surface area, which is all of the outside area. So it's not the volume of space it takes out. It's like as if I was going to cover that cylinder with wrapping paper all the way around. How much area would it take up? Now, the total surface area that I asked for in the last bit is the cylinder plus it's this curved piece at the bottom. Okay, so plus curved bit. So this is a hemispherical, which is a hemi is half a sphere. So if I get the curved or the surface area of a sphere and I divide it by 2, okay, can you see that I will work out the curved surface area of that thing? So just to repeat that, there's my hemisphere, but if I make it into a full sphere and I get the curved surface area of that, I divide it in 2, then I will have worked out the curved surface area of the inside part. Okay, so let's try that. So for a sphere, the curved surface area is 4 pi r squared. So area of my sphere is equal to 4 pi r squared. So that's equal to 4 pi, and the radius is still the same because it's still the same shape that I'm working with. Oh, sorry, I did cubed instead of squared. So 4 pi by 3.75 squared. So I'm getting 176.71 centimeters squared. Okay, so the total surface area, you'll often see it as written as TSA, total surface area, is that cylinder, okay, plus 176.71, okay, plus 235.62. So I'm getting 412.33 centimeters squared for the total surface area. Okay, why did I add it rather than take it away? Well, you need all of the outside and then you have to go inside it then because it's like a hollow bottom. So this would get added onto it. Okay, if it was a volume question, for example, I would get the volume of the cylinder. I would then get the volume of this part and take it away. But because it's curved surface area, so we're looking for all the area of the faces, it's all of the outside, and then it's in the inside, and you add it on.